Okay, today we're going to talk about another method for solving quadratic equations. When the quadratic cannot be factored, I think factoring is the best way, it's the easiest way, but sometimes factoring isn't possible. So over the weekend we practiced completing the square, which is one way of solving when factoring isn't possible, and today another method. So really our lesson today is in two parts. I want to show you how to solve quadratic equations using the quadratic formula. And then at the end of our lesson, I want to show you the discriminant and what does that mean when we find the discriminant. It gives us some good information, in particular about the graph of the quadratic. So let's start by doing some examples of just solving quadratic equations. And my note here in green is a very important first step before you even begin to use the quadratic formula, which you hopefully have memorized. If you don't, you'll need to work on memorizing that before our next test. But before you can begin using the quadratic formula, you need to make sure that the equation is in standard form, equal to 0. So here's what I mean by that. Just if there's any adding or subtracting of terms that need to be done first to get here, make sure you do that. All right, so hopefully you have this written down or you already have it committed to memory. And our next few examples will just be using this formula to get the two solutions that we're looking for this quadratic equation. All right, I think we're going to skip this and we're going to jump right into solving using the quadratic formula. So I'll just kind of walk through this first one with you. You have a couple of choices. We need to make this equal to 0 standard form. So I'm just going to choose to move these two terms, the linear and the constant term, over to the left side. Now you could have moved the quadratic term over to the right as a negative, but I just always like to keep that positive. It's not wrong if you do it the other way, it's just preference. So now I'm ready to start using the quadratic formula. And the quadratic formula says the opposite of b, and b in this case is -3, so the opposite of that is +3, plus minus the square root of b squared, -3 squared is +9, minus 4 times 1 times 1. Okay? And we'll just show it written out like that, and then we'll come back and simplify. All over 2 times 1, a is 1, which is just 2. Of course, x is going to equal all of this. All right, so simplifying, we have 3 plus minus. You always want to do the operations underneath the radical, and you follow PEMDAS underneath the radical. So we would always multiply first, and then we would subtract. So we're going to do 9 minus 4, which is 5. So we have the square root of 5, all over 2. And since I cannot simplify the square root of 5 and I can't reduce the fraction in any way, this ends up being my final two answers. 3 plus the square root of 5 over 2 and 3 minus the square root of 5 over 2. So let me just say a word about 10 through 20 even, just this part of your assignment. In these problems, your answer should be in simplified radical form, reduced fraction form. Another way of saying that is there should be no decimals in this section. No decimals. Okay, just simplified radical form. Okay, or you could end up with just a couple of integers, or they could be rational numbers, a couple of fractions, no radicals. All right, let's try this one. It's good to go. It's already in standard form, equal to 0. So maybe I can get a volunteer. Anybody want to take a shot at this one? Okay, Adam?
So first, for starting with negative b, or with b,
okay,
it would be x equals 6, or the opposite of -6 is
okay.
6.
All right.
Plus or minus the square root of -6 squared minus times 1 and 11 times 11.
Okay. I went ahead and did negative 6 squared for you.
Right.
And then all of that is over
2 times 1.
Okay. And I chose, okay, I'm thinking of another problem. Keep going, Adam, you're doing well.
All right, so first you would multiply 4 times 1, that's 4, and then 4 times 11 is 44.
Okay.
And then
36 minus 44.
right, that's negative 22. I mean, negative 12.
Negative 8.
What?
36 minus 44.
Oh, okay, I was doing it the other way. Wait, I don't even know which way. Hold on.
Yeah, do it the other way.
Okay, yeah, I'm good now.
Okay. Can you help me out with simplifying the square root of negative 8?
Do we do like we did with earlier this past week?
Huh?
So you break it down into 4, or square root of 4, square root of 2, and then I.
Okay. Now put all that together, and what do you have?
It would be 2i times square root of 2.
Okay, very good. All over 2. Okay, now at this point, we can simplify. So you need to be on the lookout for opportunities to, we would call this, reduce this fraction. If you notice, the numbers 2, 6, 2 again, all of those are divisible by 2. So I need to do that. That's what reducing is, just finding a largest common denominator and divide into all the numbers. And so my final answer here is going to be 6 divided by 2 is 3. 2 divided by 2 is 1, so that just leaves I. And then, of course, 2 divided by 2 and the denominator is still 1. So that's my final answer for this example. Any questions on how we simplify? Let me just give you a little word of warning. You really need to be able to divide into all 3 numbers by the same number. Okay, so let me just, this doesn't match the problem above, but what if my denominator was 3? Can I reduce? No. Now I could break it up into 2 parts, but remember, these 2 terms in the numerator are joined together by plus and minus. So if I divide 3 into 6, I also have to divide 3 into 2. I can't divide into 1 and not the other one. Okay, so it's all right if I wrote it as 2 plus minus 2/3 I root 2. That's fine, but I would just leave it like this. You cannot reduce because you don't have the same number besides 1 that divides into both, and onto all 3 numbers, 2, 3, and 6. Okay? I just want to pause for a second and see if you're okay with what we just did, reducing. Any questions? All right, let's try another one. Any volunteers? Okay, Thomas.
Well, first, don't you have to change the square root to x squared?
No, now that would be true if it were completing a square, but that's not required here.
Well, then start the formula, and it would be 4
Okay.
plus or minus square root of, I guess, 16, you could say,
Okay, negative 4 squared.
minus 4, and then times 3 times negative 2.
All right, very good. We'll come back and simplify that in just a minute.
And then that's all over 2 times 3.
2 times 3, which is 6. Okay, this problem in particular causes problems for many people, so Thomas, help us out with it.
Well, you have, I guess just because it's easier for me, I'm going to write down that 16. Oh, I would have done the same thing.
Good.
Okay, 16 minus 12 times negative 2 is negative 24.
Very good. So notice, you always, just like order of operations, we multiply before we subtract. So we're subtracting a negative product. So I've already seen people working this problem today, and they're doing 16 minus 24. So you really have to be careful there, because that's going to mess up your whole answer. We're subtracting a negative number, which really means what?
Adding.
We're really going to be adding these. So be very careful in situations like that. Okay, Thomas, keep going.
So then when you simplify the numbers, there gives you 4 plus or minus the square root of 40
Good.
over 6.
All right.
And that can be simplified to 2 plus or minus the square root of 40 over 3.
Let's simplify the square root of 40.
All right. We can do 4 times 10. And that'll give you 2 times the square root of 10.
Okay, I'm just going to sit there for a second and make sure everybody understands how we got 2 root 10 for the square root of 40. If you don't understand that, just let me know. Everybody good? Okay, Thomas, we're almost home. What else can we do?
And then you can simplify all of it by 2, like all of them are factors of 2.
Okay,
So you end up with 2 plus or minus, I guess, square root of 10
over what?
over 3.
Over 3, okay. And now we're done. And again, this is in that block of problems that I mentioned earlier. I think I had you write these down. 10 to 20 even, where notice our answer is just simplified radical form, no decimals. All right, any questions so far? Think you get it? Okay, now you don't have to write these red instructions because I just took those from your book. But you should write down, now we're changing our instructions just a little bit. What we're about to do is for 22 through 30. The previous problems applied to 10 through 20, even. What I'm about to do will be for 22 through 30, even. So just want you to notice the slight difference in how the answer is written. Yeah, everything's even. Okay? Now I have this written at the top of the next page, so I'm going to go over there so we can have a little bit more room. We're still using the quadratic formula. So let me see. Zan, help me out.
So it'll be x equals 10 plus or minus square root of 100 minus 4 times 35 over 6.
Okay, everybody good? Okay, if we did 4 times 3 times 5, what is that? Okay, so let's do a little mental math. We really have 100 minus 60. Okay, so we're going to have the square root of 40 all over 6. And at this point, now we're in a new section. Okay, when you start with number 22 through 30, you need to take your calculator out. So go ahead and do that. And now we're going to find the decimal equivalent of the square root of 40, rounded to 2 decimal places. So when you get the square root of 40 rounded to 2 decimal places, just raise your hand and let me know. McKinley. 6.32. Okay. Mm-hmm.
Well, couldn't you simplify the 10 plus minus the 40 over 6 first?
How?
Well, first you could turn it into 2 times the square root of 10, and then everything goes back to 2.
You could do that, but since you're going to be using your calculator anyway, I would just save the time because we'll get to the answer probably a little bit quicker. Since you're not going to have to write the simplified radical form, I would just, at this point, just use your calculator. So my 2 answers are going to be derived from doing 10 plus 6.32 divided by 2. That's going to be one answer. So who has that? Sorry? 6, thank you. Where'd I get 2? Where did 2 come from?
I said a factor of 2.
Oh. Who's got that?
7.05.
Should be 16.32 divided by 6. 2.72. All right, that's one answer. And my other answer will be just taking those same 2 numbers but subtracting them and then dividing by 6. So who has that? 0.61. And those are my 2 answers. And so that's the way your answers will be represented in this block of problems when you have a number that's not a perfect square. Now, if this were a perfect square number, I would have ended up with 2 fractions that could be reduced. Okay, is everybody clear on that block? All right, we have just enough time, I think, to talk about the discriminant. And you don't have to write the blue instructions. I just took those from your book. This is what you're going to do on problems 32 to 38 even. So really what I want you to take away from this screen, first of all, is how we find the discriminant. And here it is. It's just this part of the quadratic formula. Just the part underneath the radical, not the radical. Well, it's one thing to find the discriminant. It's another thing to know what it means as far as our graph. And so obviously, when we find this number, it's got to be one of 3 things. It's either got to be positive, 0, or negative. So you should have in your notes what happens, what does it mean for each of the 3 scenarios. What does it mean for the discriminant to be positive, for it to be 0, and negative. I just want you to write this down, and then we're going to elaborate on this just a little bit. Okay, let's just start with if the discriminant is a positive number. I told you that that means you're going to have 2 real solutions. What I mean by that is, well, let's just go back. Here we have 2 real solutions. There is no number I involved in my solution at all. What does that mean as far as our graph is concerned? Well, I'm just going to do a little rough sketch. 2 real solutions, positive discriminant means that I'm going to have a parabola, now this is just a rough sketch, that will cross the x-axis at 2 places. I have 2 x-intercepts. When the discriminant's positive, you can guarantee that your parabola should cross the x-axis twice. So it's kind of like a check. When you draw your graph and your parabola doesn't cross the x-axis twice, but you got a positive discriminant, you know something's wrong somewhere. Okay? For a discriminant of 0, that means we have 1 real solution, and for our graph, that means that we have only 1 place where the x-axis is touched. We only basically have 1 x-intercept, and what do you think that is for a parabola? And it has to open either up or down, so if that's the case, what would we call this point? Okay, what is that point on a parabola? The vertex. Okay, so when the discriminant is 0, that means that when we draw this graph, we should have the vertex sitting on the x-axis. We're only touching the x-axis once. Well, if 2 real solutions means 2 x-intercepts, 1 real solution means 1 x-intercept, what do you think no real solutions means? That means no x-intercepts. So we're going to have a graph that does something like this. I mean, it could do any number of things, but maybe it does that. It doesn't cross the x-axis at all. Maybe it does this. However you can think of a parabola that doesn't cross the x-axis, that's what we mean by a discriminant that has no real solutions. It's negative. Okay? Well, now that we know how to find it, the book uses the fancy word evaluate the discriminant. That just means use the formula, come up with the number for the discriminant. So Mackenzie, can you help me out with this first one?
Yeah, be 4 minus 4 times 25.
It's actually going to be 4 squared. And you said 4 times 1 times 5. So what would that be as a single number? -4. Everybody see that? 16 minus 20? Okay, so we just did this part. We evaluated the discriminant. Now we're going to tell how many solutions and whether they are real or imaginary. So I'm going to give you a model of how I want you to write your answer. Okay, the discriminant is negative. So what does that mean? How many solutions and what kind? 2 imaginary. So really I'm going to say it this way. No real solutions. 2 imaginary solutions. And I'm going to have you follow up with a statement about how does this apply to the graph? What do we know now about the graph of this parabola? Doesn't cross the x-axis. So I want you to follow up with a sentence. Graph doesn't cross x-axis. Okay, Brianna, what about letter B?
It'd be 20 squared minus 4 times 4 times 25.
Okay, she said 20 squared, which is 400, minus 4 times 4 times 25, which is also 400. So, evaluating the discriminant, we get 0. So how many solutions and what kind? Okay, we have 1 real solution. And how does that apply now to our graph? Okay, and we're going to say it this way. Thomas said vertex of the parabola, and we're just going to say vertex on the x-axis. That's the only x-intercept we have. Okay, and so you've got, I think, 4 of those at the end of your lesson, and that's the way you should answer them. So here's the assignment, just the evens. And there will be a separate video where I've worked some of these out, so I hope you'll check those out and at least fast forward to see if you got the answer, and then if you didn't, try again. Make sure you get it right. All right?